Determine whether the series is convergent or divergent. If it's convergent, find its sum. Well, the first thing that we always want to test, because it's an easy test, is use the divergence theorem. So we're going to look at the limit as n goes to infinity of the terms that are in this series. And as we look here, we can see that this one, if we had these multiplied by 1 over n, would be the limit as n goes to infinity of 2 minus 1 over n over 4 minus 1 over n. And so as we let n go to infinity, these two terms go to 0, and the terms in this series go to 2/4 or 1/2. So by the divergence theorem, this series diverges. And remember, the divergence theorem says if for the series to converge, the limit as n goes to infinity of the terms has to be 0. So it was 1/2, so by the divergence theorem this diverges. Now as we look at this second one, this is actually the sum of two geometric series. So let's go ahead and split this up, and the first of those is going to be 2 times 1 over 5 to the n, because this applies to both here, and I'm separating this out so we can clearly see. And then this one would be, as n goes 1 to infinity, of 3 over 5 to the n. So I used some properties and I put this 5 to the n underneath both of these terms, and then I used a property of summations to split those terms up, and then I expressed them so that we could clearly see that they are geometric and we could easily see what the common ratio is. So now I could use our formula for the sum of an infinite geometric series, which is the first term over 1 minus the common ratio. So I can do that for both of these pieces and then sum those together. So the first term is what we would get if we put a 1 in here. So that's going to be 2/5, and that's going to be over 1 minus 1/5, because this is our common ratio right here. And remember that a geometric series converges if the common ratio is, in this case, positive and less than 1. Remember that bottom line, the absolute value needs to be less than 1. We also have a convergent geometric series here because there's our r and it is also less than 1. So we're going to add that. The first term, if we put a 1 in here, would be 3/5 over 1 minus that common ratio, which is also 3/5. So now we could simplify these. This denominator is 1 minus 1/5, which is 4/5, so we could flip it over and have 5/4, and then the 5's would cancel, so it looks like that would be 1/2 plus, here we have in the denominator 1 minus 3/5, which is 2/5, so we could flip it over and have 5/2, and then the 5's would cancel, and so this would be 3/2, and then summing those together, 1/2 plus 3/2 will be 4/2, which is 2. So this is a convergent geometric series and it converges to 2.